Hey Algebra students, in this video we're going to be talking about percentages and how to solve percentage problems. Now this is not really hard as long as you follow the pattern. Make sure that you know how to write percentages as word sentences, as equations. There's two ways I'm going to be teaching how to do this. You need to be familiar with both. Okay, let's get started. What is a percentage? A percentage is a part divided by a whole, but then we compare that part divided by a whole to 100. Let me give you an example of this. So let's say that we are trying to figure out what the percentage of girls is in our algebra class. Now, we have a whole number of students in our algebra class, and we have a smaller number that's the number of girls in our class. If I divide that part, the number of girls, by the whole number of students in algebra class, that would give me a number, okay? And what we do with percentages is we say, well, you know, we're going to have a number of maybe 15, 22, 23, like some weird number of total students in our class. So a number like 12 out of 22 or 12 out of 27 or something. Those are just really strange numbers for your brain to grasp. But you know what's not hard for your brain to grasp? A number out of 100. 100 is like the perfect number because it's really easy for your brain to conceptualize. It's not too big, not too small. It's just this great number that your brain can easily make sense of. So with percentages, we say, all right, so there's not 100 students in algebra class, but what if there was 100 students in algebra class? If there were 100 students, how many of those students would be girls? And then when we extrapolate the number of girls in algebra class, instead of having a whole number, we might have a decimal number because we're extrapolating. We're stretching the number out as if it were out of 100. So weird things sometimes happen with that. That's what a percentage is, though. We compare a number to 100. And when we compare a number to 100, it makes it easy for our brain to conceptualize what it is that we're talking about. Notice that a percentage is made up of two parts, a part and a whole. We divide the part by the whole, and then we have to do something to change it so that it's like it's out of 100. And what are we going to be doing to change it? We're going to set up proportions, or we're just going to multiply. Here's the other form of a percentage. Now, by the way, this is a valid way of writing a percentage, a number divided by 100. But the more common way that you're used to seeing percentages are as just what's called a unit rate. We've learned about unit rates. So to make a percentage like this into a unit rate, what do? We just actually do the division, and then we put this little percent symbol behind it. And this tells us the ratio of the percent, the part, okay, we sometimes call this the percent, sometimes call it the part, to the whole. And that's what we're going to be doing in our practice problems is we're going to be setting these up as percentage problems. And we're going to be doing it one of two ways. We're either going to do it with this number sentence. By the way, just remember, of in a number sentence means times, is means equals. And if I wanted to, I could flip this around so that this part is on the other side. So it'd be 5 equals 25% times 20, okay? We could do that, or we could set it up as a proportion. Let's get started doing it one of those ways. We're going to start with letter A here. And actually, I have these all worked out. So let's just take a look at how we work this out. Now, I need to set this up. What number is 35% of 70? Here's how I'd set that up. X is what number? Is an equal sign. 35% of 70 means 35 times 70. So I need to do 35 times 70 to get this answer. I'm just going to do that over here on the right. 70 times 35. But wait a second. Times 35? Well, it's 35%. Remember, 35% is actually 35 divided by 100. That's what a percent is. So we could actually just get rid of the percent sign. We need to in order to do arithmetic and move the decimal place over 2 places to the right. This becomes 0.35 instead of 35%. Then I do the multiplication, 70 times 0.35. You can see things worked out over here. Make sure when you get to the step at the bottom, once you've added your two numbers, you go back and count how many decimal places you have to move over. 1, 2, there's 2. So I have to put my decimal place 2 over. I get a number 24.5. And then you need to ask yourself whether it's a realistic answer. Well, 35% is less than 50%. So it should be a number that's less than half of 70. Half of 70 would be 35. 24.5 seems like it's right in the range where it should be. All right, letter B. What number is 150% of 24? You're going to find out Saxon math loves percentages that are bigger than 100%. We have a percentage that's bigger than 100%. What we're saying is that the part is actually bigger than the whole. And these are the harder ones to work out. And that's why Saxon math loves them so much, because percentage problems are too easy if you never deal with percentages over 100. So be ready. How does this one get set up? Well, to set this one up, it's going to be B equals 150% times 24. 150% can be rewritten, if I don't write it in percent form, like up here above, as 150 over 100, or 1.5 if I just move that decimal place to the left. If I do this multiplication, this is not hard multiplication to do. 1.5 times 24, it's just 24 plus half of 24. It should equal 36. That's 150% of 24. All right, let's take a look at letter C. In letter C, we're asked to use a proportion to find 315% of 21. Now here's another thing Saxon likes to do. Man, it's tempting to do a cross cancellation here. But cross canceling can only happen when you're multiplying two numbers, two fractions together, not when they're on either side of an equal sign. I can cancel things on the top of the fraction, on the bottom of the fraction. I don't recommend trying to remember to do that. What I recommend is when you have things on either side of an equal sign, you just do the cross multiplication that you know you have to do for a proportion problem, like this. This is going to be 21 times 315 equals 100 times x. Divide both sides by 100. We get 21 times 315 over 100. And then this one is not too difficult. What I can do here is just divide the 315 by 100. Remember, I'm not distributing this 100 to both because these aren't being added on top. That just means that one of these two numbers on top has to be divided by 100. So I'm going to do the 3.15. I'm going to do my multiplication here. Here's my long multiplication again. Move my decimal place over 2 places at the end. I get 66.15. Is that realistic? Well, 3.15, let's see, 315% is 3 times and then a little more. 3 times 21 is 63. And then it's going to be a little more than 3 times 21. 66.15 seems realistic. All right, let's look at letter D. 59.5 is what percent of 17? Oh, hey, the other two problems. What number is? What number is? Using proportion, find the number that is 315% of 21. Now we're being asked what percent. So this one's a little different. How do I set up a what percent question? Well, here, my what percent, the percent is the number over 100. So I'm just going to do this in proportional form, and I'm going to put my unknown above 100. Somewhere my unknown is going to have to go above 100 for me to change it to a percent. Okay, so this is going to be, let's see, what is my whole and what is my part? 59.5 is what percent of 17? Well, if I'm asking this big number here is what percent of this small number here, I'm going to have a percentage that's over 100%. 59.5 is the part, 17 is the original whole number I'm multiplying by the percentage. So I'm going to have this set up. 59.5 over 17 equals the percentage. You have to ask yourself, okay, when they're saying that this is the setup for this problem, what are they saying is the whole? What are they saying is the part? Remember, the whole is the thing that gets multiplied times the percent. What are they saying I'm multiplying the percent by? I'm going to multiply the percent by 59.5. Another way to think about this is I could just set this up just like a number sentence. I should have done that. I did this proportionally, but man, if you ever get confused by what goes where, set it up as a number sentence. 59.5 equals what percent is, I can't stress it, x over 100. anytime you see what percent, x over 100. You have to remember to divide by 100 times 17. So this could have been correctly written, 59.5 equals x over 100 times 17. In the end, what am I going to have to do? Well, I'm going to have to do a division problem here. This is cross multiplied. This is what you would solve for to get x, 5,950 divided by 17. 5,950 goes under the division symbol, and then 17 goes out front. Here you can see the long division worked out. That comes out to 350%. Now remember, because I already had the over 100, I don't have to do anything with the decimals of this. Whatever this is, 350, that is my percent. And that makes sense because I would have to multiply 17 times 3 and more to make 59.5. In fact, I could figure out it's exactly 3.5. That's 350%. All right, then the word problems. Let's take a look at E. A driver who accelerates quickly and brakes heavily reduces his car's fuel economy by as much as 33%. This is a hard problem because they're saying that you reduce your car's fuel economy by as much as 33%. What that means is you're only getting 67% of your car's fuel economy. I've worked this out in a very specific way, and I want you to see how I did this. So the car's supposed to get 32 miles per gallon. Use an equation to find the actual fuel economy of the car. Well, let's see how we do this. So 33% of 32 is what? Okay, 33% of 32 is what? I put it in sentence form, and then I put it in equation form. This is going to be 33 out of 100 times 32, which is same as 33 times 32 out of 100. Here you can see me working out 33 times 32 over on the right. It's 1,056. But then I need to divide that by 100. I get 10.56. Is that my answer? I get 10.56 miles per gallon? No. I get 10.56 less miles per gallon than I'm supposed to. There's one more step. That's a subtraction step. I need to subtract that less gas mileage from the original, and that gives me how much I actually get, 21.44. All right, then this last one, I did this with a calculator. If this one came up on a test, I would let you use a calculator for this one. You could do this with long multiplication. It's not really all that hard, but it's a little too much work, just a little too much work. All right, so school raised $15,432 for a new computer lab. The money will be allotted as follows: 50% for construction, 45% for technology, and then the rest, who cares? Because the question is, find the amount that will be spent on technology. So that's the only percent I care about, 45%. So we're going to do 45% times 15,432. Let's say this as a number sentence just to make sure. 45% of the amount raised, $15,432, is what amount? 45% times 15,432 equals X. And then you just punch that into a calculator. That's the best way to do this one. Find that there's $6,944, and that last 40 cents is very important. I'm sure maybe you can buy some kind of, I don't even know what you would buy with technology with 40 cents, but it's important because it's part of the answer. You do need to make sure that you have the entire dollar and cents amount there. All right, you are ready to do numbers 1 through 34 next time. Go ahead.